This is a graph of y equals e to the power of negative x squared. So in the previous video, I showed you how you can work out the volume of this thing when you revolve it 360 along the y-axis. So we can work out the volume of this thing by summing up all the disks. So in the previous video, we used this method here where we summed up all the disks. But it turns out that if you use cylindrical shells, it would be a lot easier. So in this video, we're going to use cylindrical shells. So the idea behind cylindrical shells is that you're moving along in the x direction. You can see you're moving in the x direction. So your volume would be v something along the x direction, and then each step of the way. So this is your tracker. This is your tracker x. So let's say x is currently here. You need to 2 pi r it to get the circumference. So you need to 2 pi r. This is the radius here. You need to 2 pi r it to get the radius. But the radius is actually x itself. So the radius is x. So suppose x is over here. The radius is x. So we can replace this with x. So this thing here will give us the circumference of the cylinder, and then we will need to times by the height of the cylinder. So the height of the cylinder is given by, well, if you want to know the height, you would put this x into here, and then it will jump to here to the function. So the height is given by e minus x squared. And then you're summing up all the cylinders. Suppose x is over here. If you 2 pi r this, that will then give you this circumference. And then when you times by the height, you're going to get a cylinder. So you're really summing up all the cylinders. So the idea here is we're going to do it from hang on. So let's start again here. We're gonna move in the v is given by this. We're going to move. It's going to be something dx, because we're moving in the dx direction. So suppose x is here, 2 pi r it, that will then give you your circumference. So 2 pi r is x here, and then we will need to times by the height of the cylinder. So the height of the cylinder is given by this. So that would be e minus this thing here, and then we're integrating it from 0 to, well, we want to take it all the way to infinity, but let's do it to b. So we're going to integrate it to b. So this is the volume from 0 to b. So this is a volume from 0 to b. So that's the volume from 0 to b. But later on, when we want the whole volume all the way to infinity, then v itself will be, when you take the limit as b heads towards infinity of this thing here. Hang on, of this thing here. So that's the idea. Let's just try to integrate it from 0 to b first, and then later on we will take the limit. So let's try and work out the volume from 0 to b first. So the volume from 0 to b is given by this. It's basically this thing here. So it's given by this. It's given by this. So now 2 pi is a constant, so we can take it out here. That will then take us to here. And then when you look at this, you know this is going to be easy to integrate. Whenever you get something being the derivative of another thing, then you know it's going to be easy to integrate. For example, this is a derivative of this, or this is a derivative of this. You know it's going to be easy to integrate. So let's try and integrate this. When you integrate it, you're really looking for something in such a way that when you differentiate it, it will give you this whole thing here. So let's make this to be our initial guess. Hang on. So our initial guess is going to be e to the power minus x squared. So now when we differentiate this, it will then give us, well, imagine this as a bubble here. imagine this is a bubble. So when you differentiate e to the power of the bubble, it would just be e to the power of the bubble. It would just be e to the power of the bubble. But then you would need to times the derivative of the bubble itself, which will be negative 2x. So when you tidy this thing up, it will be negative 2x e, and then the bubble, which will be negative x. You can see that this thing here is pretty much the same as this. So, but we just need to negate this negative 2. So we would need to go back to our initial guess and then make the adjustment. If you stick a negative 1/2 in here, now when you differentiate it, it would just give you this thing here. So basically, to integrate this, it would be this thing here, which is this thing here. You could use substitution, but because this is so easy to integrate, you can just make your initial guess and guess the answer. So this is, well, integrate this, or you can use substitution, but just because this is quite straightforward, just integrate it. It will then give you this from 0 to b. So this is a constant, so we can take it out here. The two 2's will cancel each other out, giving you negative pi. So now, hang on. So now we can put this into here. That will then give us this, and then take away, put 0 into here. That will then give you this. E to the power of 0. So this is the volume from 0 to b. This is the volume from 0 to b. Remember, we're summing up all the cylinders. We're summing up all the cylinders. So we're summing up all the cylinders from 0 to b. And then now, if we want the whole volume all the way to infinity, then the whole volume would be given by us taking the limit as b heads towards infinity. Now, when this thing here when b heads towards infinity, b squared would be very, very big. So in your mind, think of this. Think of a very, very big number. And then if you look at the normal e graph, which looks like this. Now e to the power of negative, very, very big. You can see that it's heading towards 0. E to the power of negative something is going to head towards 0. So this thing here will be 0. So this, as you take the limit as b heads towards infinity, this thing here will be very, very big. You've got a negative very, very big, making the whole thing here 0. So this thing here becomes 0. Well, this is just a constant. So this is just a constant. So it really becomes pi. So the volume of this thing here from 0 all the way to infinity, if you revolve it 360 along the y-axis, the whole volume would be given by pi. Okay.